Digital imaging and communications in medicine is a standard for handling, storing, printing, and transmitting information in medical imaging. It includes a file format definition and a network communications protocol. The communication protocol is an application protocol that uses TCP/IP to communicate between systems. DICOM files can be exchanged between two entities that are capable of receiving image and patient data in DICOM format. The National Electrical Manufacturers Association holds the copyright to this standard. It was developed by the DICOM Standards Committee, whose members are also partly members of NEMA. DICOM enables the integration of scanners, servers, workstations, printers, and network hardware from multiple manufacturers into a picture archiving and communication system. The different devices come with DICOM conformance statements which clearly state which DICOM classes they support. DICOM has been widely adopted by hospitals and is making inroads in smaller applications like dentists' and doctors' offices. DICOM is known as NEMA Standard PS3, and as ISO Standard 12052-2006 Health Informatics, Digital Imaging and Communication in Medicine including Workflow and Data Management. Parts of the standard, the DICOM standard is divided into related but independent parts. The links below are to the 2011 version. Additions to the standard since that publication are available through the DICOM website. PS 3.1 Introduction and Overview PDFA, 241 KB, PS 3.2 Conformance PDFA, 6.46 MB, PS 3.3 Information Object Definitions PDFA, 6.96 MB, PS 3.4 Service Class Specifications PDFA, 1.07 MB, PS 3.5 Data Structure and Encoding PDFA, 588 KB, PS 3.6 Data Diction PDFA, 7.32 MB, PS 3.7 Message Exchanger PDFA, 1.97 MB, PS 3.8 Network Communication Support for Message Exchanger PDFA, 901 KB, PS 3.9 Retired, PS 3.10 Media Storage and File Format for Media Interchanger PDFA, 406 KB, PS 3.11 Media Storage Application Profiles PDFA, 398 KB, PS 3.12 Media Formats and Physical Media for Media Interchanger PDFA, 302 KB, PS 3.13 Retired, PS 3.14 Grayscale Standard Display Functioner PDFA, 478 KB, PS 3.15 Security and System Management Profiles PDFA, 753 KB, PS 3.16 Content Mapping Resourcia PDFA, 5.03 MB, PS 3.17 Explanatory Information PDFA, 11.40 MB, PS 3.18 Web Access to DICOM Persistent Objects PDFA, 203 KB, PS 3.19 Application Hosting PDFA, 1.22 MB, PS 3.20 Transformation of DICOM to and from HL7 Standards PDFA, 570 KB. History. DICOM is the first version of a standard developed by American College of Radiology and National Electrical Manufacturers Association. In the beginning of the 1980s, it was very difficult for anyone other than manufacturers of computed tomography or magnetic resonance imaging devices to decode the images that the machines generated. Radiologists and medical physicists wanted to use the images for dose planning for radiation therapy. ACR and NEMA joined forces and formed a standard committee in 1983. Their first standard, ACR NEMA 300, was released in 1985. Very soon after its release, it became clear that improvements were needed. The text was vague and had internal contradictions. In 1988 the second version was released. This version gained more acceptance among vendors. The image transmission was specified as over a dedicated two-pair cable. The first demonstration of ACR NEMA v2.0 interconnectivity technology was held at Georgetown University. May 21 to Euro 23, 1990. 6 companies participated in this event: Dejanet Research Systems, General Electric Medical Systems, Merge Technologies, Siemens Medical Systems, Vortec and 3M Commercial Equipment. Supporting ACRN EMA 2.0 was presented at the annual meeting of the Radiological Society of North America in 1990 by these same vendors. Many soon realized that the second version also needed improvement. Several extensions to ACRN EMA 2.0 were created, like Papyrus and SPI, driven by Siemens Medical Systems and Philips Medical Systems. The first large-scale deployment of ACRN EMA technology was made in 1992 by the U.S. Army and Air Force, as part of the MDIS program run out of FT Detrick, Maryland. Loral Aerospace and Siemens Medical Systems led a consortium of companies in deploying the first U.S. military PACS at all major Army and Air Force medical treatment facilities and teleradiology nodes at a large number of U.S. military clinics. Dejanet Research Systems and Merge Technologies provided the modality gateway interfaces from third-party imaging modalities to the Siemens SPI network. The Veterans Administration and the Navy also purchased systems off this contract. In 1993 the third version of the standard was released. Its name was then changed to Dicom so as to improve the possibility of international acceptance as a standard. New service classes were defined, network support added and the conformance statement was introduced. Officially, the latest version of the standard is still 3.0. However, it has been constantly updated and extended since 1993. Instead of using the version number, the standard is often version numbered using the release year, like the 2007 version of Dicom. While the Dicom standard has achieved a near-universal level of acceptance amongst medical imaging equipment vendors and healthcare IT organizations, the standard has its limitations. Dicom is a standard directed at addressing technical interoperability issues in medical imaging. It is not a framework or architecture for achieving a useful clinical workflow. RSNAs integrating the Healthcare Enterprise Initiative layered on top of Dicom provides this final piece of the medical imaging interoperability puzzle. Derivations: there are some derivations from the Dicom standard into other application areas. These include, Dicom, Digital Imaging and Communication in Non-Destructive Evaluation, was established in 2004 as a way for non-destructive testing manufacturers and users to share image data. DICOS, Digital Imaging and Communication in Security was established in 2009 to be used for image sharing in airport security. Data format: Dicom differs from some, but not all, data formats in that it groups information into data sets. That means that a file of a chest X-ray image, for example, actually contains the patient ID within the file, so that the image can never be separated from this information by mistake. This is similar to the way that image formats such as JPEG can also have embedded tags to identify and otherwise describe the image. A Dicom data object consists of a number of attributes, including items such as name, ID, etc., and also one special attribute containing the image pixel data. A single Dicom object can have only one attribute containing pixel data. For many modalities, this corresponds to a single image. But note that the attribute may contain multiple frames, allowing storage of scene loops or other multi-frame data. Another example is NM data, where a nanometer image, by definition, is a multidimensional multi-frame image. In these cases, 3 or 4-dimensional data can be encapsulated in a single Dicom object. Pixel data can be compressed using a variety of standards, including JPEG, JPEG lossless, JPEG 2000, and run-length encoding. LZW compression can be used for the whole dataset, but this has rarely been implemented. Dicom uses 3 different data element encoding schemes. With explicit value representation data elements, for VRs that are not OB, OW, OV, SQ, UT, or UN, the format for each data element is group element via length and byte data. For the other explicit data elements or implicit data elements, see Section 7.1 of Part 5 of the DICOM standard. The same basic format is used for all applications, including network and file usage, but when written to a file, usually a true header is added. Image display. To promote identical grayscale image display on different monitors and consistent hard copy images from various printers, the DICOM committee developed a lookup table to display digitally assigned pixel values. To use the DICOM grayscale standard display function, images must be viewed on devices that have this lookup curve or on devices that have been calibrated to the GSDF curve. Value representations, extracted from Chapter 6.2 of PS March 5, 2007, Data Structure and Encoding PDFA, 1.43 MB. In addition to a value representation, each attribute also has a value multiplicity to indicate the number of data elements contained in the attribute. For character string value representations, if more than one data element is being encoded, the successive data elements are separated by the \character \. Services. DICOM consists of many different services, most of which involve transmission of data over a network, and the file format below is a later and relatively minor addition to the standard. Store. The DICOM store service is used to send images or other persistent objects to a picture archiving and communication system or workstation. Storage commitment. The DICOM storage commitment service is used to confirm that an image has been permanently stored by a device. The service class user, a modality or workstation, etc., uses the confirmation from the service class provider, an archive station for instance, to make sure that it is safe to delete the images locally. Query retrieve. This enables a workstation to find lists of images or other such objects and then retrieve them from a picture archiving and communication system. Modality worklist. This enables a piece of imaging equipment to obtain details of patients and scheduled examinations electronically, avoiding the need to type such information multiple times. Modality performed procedure step, a complementary service to modality worklist. This enables the modality to send a report about a performed examination including data about the images acquired, beginning time, end time, and duration of a study, dose delivered, etc. It helps give the radiology department a more precise handle on resource use. Also known as MPPS, this service allows a modality to better coordinate with image storage servers by giving the server a list of objects to send before or while actually sending such objects. Printing. The DICOM printing service is used to send images to a DICOM printer, normally to print an X-ray film. There is a standard calibration to help ensure consistency between various display devices, including hard copy printout. Offline media. The offline media files correspond to Part 10 of the DICOM standard. It describes how to store medical imaging information on removable media. Except for the dataset containing, for example, an image and tomography, it's also mandatory to include the file meta information. DICOM restricts the file names on DICOM media to 8 characters. No information must be extracted from these names. This is a common source of problems with media created by developers who did not read the specifications carefully. This is a historical requirement to maintain compatibility with older existing systems. It also mandates the presence of a media directory, the Dicom file, which provides index and summary information for all the DICOM files on the media. The Dicom information provides substantially greater information about each file than any file name could, so there is less need for meaningful file names. DICOM files typically have a DCM file extension if they are not part of a DICOM media. The MIME type for DICOM files is defined by RFC 3240 as application Dicom. The uniform type identifier type for DICOM files is org-name Dicom. There is also an ongoing media exchange test and connect-athen process for CD media and network operation that is organized by the IHE organization. MicroDicom is free Windows software for reading DICOM data. Application areas. extracted from Chapter C7.3.1.1.1 of PS March 3, 2011, Information Object Definitions a PDFA, 6.51 MB, port numbers over IP, DICOM have reserved the following TCP and UDP port numbers by the Internet Assigned Numbers Authority, 100 for well-known port for DICOM over Transmission Control Protocol or User Datagram Protocol. Since 104 is in the reserved subset, many operating systems require special privileges to use it. 2761 registered port for DICOM using Integrated Secure Communication Layer over TCP or UDP, 2762 registered port for DICOM using Transport Layer Security over TCP or UDP, 11112 registered port for DICOM using Standard, Open Communication over TCP or UDP. The standard recommends but does not require the use of these port numbers. Disadvantages. According to a paper presented at an international symposium in 2008, the DICOM standard has problems related to data entry. A major disadvantage of the DICOM standard is the possibility for entering probably too many optional fields. This disadvantage is mostly showing an inconsistency of filling all the fields with the data. Some image objects are often incomplete because some fields are left blank and some are filled with incorrect data. HL7, DICOM is a standard for handling, storing, printing, and transmitting information in medical imaging. The communication protocol is an application protocol that uses TCP/IP to communicate between systems. DICOM files can be exchanged between two entities that are capable of receiving image and patient data in DICOM format. The National Electrical Manufacturers Association holds the copyright to this standard. It was developed by the DICOM Standards Committee, whose members are also partly members of NEMA. Health Level 7 is a non-profit organization involved in the development of international healthcare informatics interoperability standards. 1. HL7 also refers to some of the specific standards created by the organization. The HL7 Strategic Initiatives document is a business plan for our products and services and was designed specifically to meet the business needs of its members and stakeholders. Derived from collaborative efforts with its members, government and non-government agencies and other standards development organizations, the strategic initiatives are 5 high-level organizational strategies that are supported by a detailed tactical plan with clearly defined objectives, milestones, and metrics for success. Both of the standards are focused on the data exchange and the data compatibility. Among many standards for the syntax, HL7 and DICOM are most successful. However, everything could not be handled by HL7 solely. DICOM is good for radiology images, but other clinical images are already handled by other EuroLite or Euro1 registered trademark data formats like JPEG, TIFF. So, it is not realistic to use only one standard for every area of clinical information. Opening the HL7 and DICOM standards in order to foster the integrated use of persistent health information objects is proposed as a step towards the creation of the health information infrastructure. IHE, Integrating the Healthcare Enterprise, was founded in 1997 by members of the Radiological Society of North America and the Healthcare Information and Management Systems Society for the purpose of improving interoperability between information systems. The IHE initiative was charged with the task of using existing standards of healthcare data communication such as DICOM and HL7 to improve exchange of medical information beyond the radiology department at the hospital level or health systems level. Just as radiologists were confronted in the past with imaging connectivity incompatibilities, entire health systems are continually faced with the task of connecting multiple disparate information systems in which the only reliable communications pathway is the paper printout. The IHE Working Group is a panel made up of industry representatives from medical informatics and imaging vendors as well as medical professionals. Their primary focus is to develop a common information model of medical information exchange. The devised IHE technical framework consists of a common lexicon that defines specific medical information transactions using the existing standards of medical information exchange. The specifics of these transactions have been worked out in great detail so that vendors have been free to independently develop solutions to meet the goals of the technical framework. In the year 2001 to 2002, 30 companies took part in the testing and implementation of the IHE demonstrations. See also, Dicom's software, 3dslicer, a free, open-source software package for image analysis and scientific visualization, with the integrated support of components of Dicom standard, GDCM, grassroots Dicom library for medical files. Ginkgo CADX cross-platform Dicom viewer, micro-Dicom, Dicom viewer for Windows, Ozeri X, image processing application dedicated to Dicom images, Authink, lightweight, RESTful Dicom store, XNView, supports Dic/Dicom for MIME type application Dicom, medical records standards initiatives, standards and organizations, Health Level 7, a non-profit organization involved in the development of international healthcare informatics interoperability standards, integrating the healthcare enterprise, an industry-sponsored non-profit organization based in the U.S. state of Illinois. References. External links, Dicom Standard, NEMA. Brief Introduction to Dicom, Medical Image FAQ Part 2, Standard Formats including Dicom, Medical Image FAQ Part 8, contains a long list Dicom's software. Dicom Tutorial, Dicom is easy.